Alright, here are the 5B1 notes where we're going to model exponential functions that have a percent of increase or decrease. And we've kind of already talked about this before when I was talking about saving money and how that money grows exponentially over time. So let's look at this example. Suppose you work hard all summer and save up $2,000 to start a savings account. You check out many different investment options and decide it would be best to invest your money in a mutual fund that earns 10% interest every year. Fill in the table below to help you write an equation to represent this situation. Our B value is 1.10 because our growth, we have 10% as our growth rate. So what we're going to do is we start off with $2,000. Then we're going to multiply this by 1.10. And the reason why it's 1.10 because we are growing by 10%. So on my calculator, we'll be doing 2,000 times 1.10. And we get 2,200. So after 1 year, we have that amount of money. Then we multiply by 1.10 again. And actually, times so we get 2,420. And we're going to keep going, multiplying the previous answer by 1.10. So 2,622. Sorry, 2,662. Then 2,928.2. And keep doing that. So times 1.10 times 1.10. So I will let you fill in the rest of these. Go ahead and do that real quick. Alright, now we're going to write an equation. So remember our equation, y equals a times b to the x power. We start out with $2,000, so y equals 2,000 times 1.1 to the x power. So that is our equation. Now part B, how much money will be in the account after 15 years? So we will just plug in 15 for x. So we can get our calculator out. So 2,000 times 1.10 to the 15th power, we will have $8,354.50. $8,354.50. You must have units. So $8,354.50. Now, instead of that mutual fund, instead of using that, let's pretend we place our money in a savings account that only earns 4% annual interest. So it's going to be almost the same equation, except instead of this 1.10, our new b value is 1.04. So y equals 2,000 times 1.04 raised to the 15th power. So we can just go back up here and change this to 0.4. And look at it, it's $3,601.89. So significantly less money by having a lower interest rate. Alright, so we've only talked about our money growing, but your money could also go down by a percentage as well. So the general form for talking about growing or decreasing by a percentage is y equals a, our y-intercept, our starting value, and then in parentheses 1 plus or minus our rate to the t power, where a is our starting amount, r is our growth rate, or growth percentage, this as a decimal, and t is time. So if we were going down by 10%, it would be minus 0.1 right here. Right here. Alright, so let's flip the page and look at some examples. So your grandpa gave you a baseball card that he bought in 1930 for $1.50. He told you that his value would increase by 5% each year. That word increase means that in the formula up here, we are going to be using the plus in the middle. So 1 plus 5%. So write a model. Y equals, it starts out being $1.50 times 1 plus 5% as a decimal is 0.05. Okay, we move the decimal back, move the decimal forward twice. 5% is 0.05. A common mistake is to say 5% is 0.5. 50%, that is 0.5. So 1 plus 0.05 to the x power. Now we're going to combine this part. Equation will be y equals $1.50 or 1.50 times 1.05 to the t power, or x power. It doesn't matter if you write x or t there. A lot of people write t because that implies time. Now, how much is a card's projected value today? Well, that was in 1930, and it is the year 2020, so luckily that's easy for us to say that's about 90 years. So y equals 1.50 times 1.05 to the 90th power. So 1.50 times 1.05 to the 90th power, and we get $121, and that would round up to 10 cents. So 121.1 dollars. You could also write it with the money sign in front. Instead, both answers are perfectly acceptable. Alright, our next example, Amelia and Jamal both started ant farms. There was a 2-for-1 deal, so Jamal bought 100 ants to start his farm, He tried really hard to take care of them, but didn't do enough research on what ants need to survive. Unfortunately, each week, 20% died. Okay, since 20% died, that means in our equation we're going to do minus 20%. How many did he have after 4 weeks? So y equals, we start out with 100 times 1 minus, well, 20% is 0.20. So minus 0.20 raised to the t power. Now, you could combine this before typing that into your calculator, or if you type this into your calculator with parentheses, it will still give you the same answer. I just like to always make things a little bit simpler. And now we're going to plug in 4 for t. So 100 times 0.8 to the 4th power. So we're down to 40.96. Now, here's the thing. When we're talking about people or things that you really can't cut in half, you can't have 0.6 ants. So we are going to round that to just 40 ants as our answer. When you're dealing with people or things like that, always round down. You know, for an example, if we were talking about how much weight an elevator could hold, and we got 40.96, that the elevator could hold 40.96 people, if we rounded that up to 41, we are now overweight for the elevator, and it would crash. So always round down. Alright, now, Amelia spends $8.50 to start her ant farm. However, she learned in her science class about ants and was able to take good care of her ants. Her ant population actually grew by 14% each week. After 10 weeks, she had approximately 150 ants. How many ants did she start with? So this is a little bit different. We don't know how many ants she started with. We do know that she ended with 150. We knew that we grew by 14% each week. Well, 14% is 0.14. And we know that our time is 10. So what we're going to do is we're going to plug 150 in for y. So 150 equals, we don't know our a value, our starting value. But we know that we have 1 plus 0.14 because that is our growth rate. We grew by 14% each week, raised to the 10th power. Okay, so we'll solve this. 150 equals a times 1.14 to the 10th power. So we're going to type this into the calculator. Point 0.14 to the 10th power, and we get 3.71. So 150 equals 3.71 times a. You know, when I typed in to the calculator 1.14 to the 10th power, we got 3.71. Now we will divide both sides by 3.71. So 150 divided by 3.71. And we get 40.43 equals a. And again, since we're talking about ants, actual things, we need to round that down to 40 ants. All right, so that's it for this lesson. Just keep in mind that when you are growing, you are going to add that percentage, and when you are losing value or decreasing, you're going to subtract. Up here, you know, it might be a good idea, to say, growing or increase means plus, you know, decrease, that's going to be minus. All right, so the homework is on the next page, so please get started on that and let me know if you have any questions.